OAuth 2 is the de facto standard for web authorization, and while there are plenty of libraries in Python that can do it for you, sometimes it's better to know something from scratch, especially when it comes to your online security. So in this video, we are going to be going over the full OAuth 2 workflow, and then we're going to be implementing it in Python from scratch using the request library. So we're going to be authorizing to request an access token. We're going to be checking that access token's validity, and we're going to be refreshing that access token. And once all that's done, we are going to be optimizing the workflow to make our solution even smarter. Of course, if you found the video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. And if you want to see them earlier than anyone else, then consider becoming a member or a patron by using the links in the description below. But with all that out of the way, let's go over how OAuth 2 authorization works. So before we get into the meat of the code, I'm going to create a little diagram to help kind of explain what the OAuth 2 process is and what we need to map into code. I've already got the AI prompt set up, and hopefully it will generate the right thing, and then we can just edit it as necessary. Just a bit easier than typing it all out. Yeah, so we start with, and let me just wait until it's all done and I can zoom in to it. Okay, there we go. So if I just zoom in, there we go. So in our OAuth 2 flow, we have 4 entities. We have our user, we have our client, we have our authorization server, and we have our resource server. So the resource server is just the normal server. Once you're authorized, you can access it and get resource back down. Authorization servers sit in the middle. They are the things that handle the authorization. The client is just your application, and the user is you. So first you access the application, and then the client redirects to the authorization server. It then asks you to authenticate yourself. You provide authentication credentials, such as a username or password or something. And then it will request authorization, and then you can grant authorization. So this is just saying, do you want to actually allow this service to use your data, basically. And then once you say yes, the authorization server will give an authorization code. You can have it send the code to the user. You might have seen that before, and then the user passes it in. We're not going to be doing that here. We're going to be doing as the diagram suggests, and we're going to be using something called loopback IP addressing, or at least that's how Google calls it, sending the authorization code to the client, which will then request the access token using it, and then it gets the access token and refresh token back. And then you can use these tokens to then request access to protected resources. So that's the general flow of how everything works. If we go into our window, we can see that I already have a secrets.json file. And this is an actual Google project of mine that I'm going to have to invalidate once I'm done here, but that's fine. Your secrets might look slightly different because there's no standard as to how secrets are provided, though you do need at least the client ID, the client secret, the redirect URLs, and then you might have an authorization and token URI in here, or it might be given to you in some other way. But you need the client ID, the auth URI, the token URI, the client secrets, and the redirect URI in full. These 2 things here are just Google stuff and are not actually important for us. So if we go into our script, we need to import actually quite a few things, and I'm going to import everything at once. So we need to import #lib. Oh God, I've already screwed that up. We need to import JSON. We need to import OS. We need to import web browser. We need to from http.server import base HTTP request handler and HTTP server. We need to from pathlib import path, and we need to do from URL lib.parse import parse QSL, and then URL in code. And then we also need to go into here. We need to do pip install requests. If you don't have it already, we're just going to be using requests for this. You can use AO, HTTP, or whatever if you like. We're using requests, and then we need to import that as well. So that's a lot of things to import straight off the bat. We'll talk about how we use each as we go through it. But that just saves me having to scroll up to the top and kind of scrolling manically around the place. So we're going to start by defining a series of scopes that we want to authorize with. I'm going to be using Google scopes because Google is what I know. And I did try and find something that would have let me do this without any accounts or whatever. The OAuth 2 playground is the closest I got. I'd recommend that if you do want to learn more, but you can't go through the full workflow programmatically with it, which is really annoying. So we'll start with Google. So I'm actually going to copy these in for my notes. So in this case, we have scopes. So basically, YouTube Analytics read only and YouTube Analytics monetary.read only. They don't have to be URLs. Google just tends to make them URLs. You can put as many scopes or as few scopes as you like in here, but these will be dependent on the API you're connecting to. And we want to set a host, which in this case is going to be localhost. And this will be important later. And we're going to do a port 8080, and that will also be important later. And we are going to now do our run guard if name double equals main. And then we're going to load our secrets in using json.loads, and it might actually do the rest. There we go. So we're loading our secrets.json file. We're reading the text and loading into JSON. I am then going to get the secrets out because you'll see it's nested inside this installed thing, and we don't want that. So we're just going to get it out of there. And then we're going to do our tokens equals authorize, which is a method we're going to, or a function, sorry, we're going to create. We're going to pass the secrets in, and then we're going to print the tokens out to the terminal. So coming up here, we create our authorize file function. I can't talk. I've just done a full day of work and my brain is apparently mush. So this is going to go really well. And we're going to have secrets, and this is going to be a dict of string to string. And then this is going to return a dict string to string, which is our tokens. And then we want to set the redirect URI manually to be, in this case, the redirect URI in our secrets file, the first one, because Google provides multiple. And then we also want to stick a port on the end of it. And this is important. You don't have to do this if it's actually hosted online. So if you're hosting it on a website, you can use port 80 and that will be the default. We can't use that with localhost, so we're actually having to specify a port. And I'm going to get my Pi to shut up for a second. Yeah, Google has multiple redirect URIs in its secrets, so you might just need to do secrets, redirect URI. And then we're going to provide a series of parameters that we want to pass as query parameters. And we're going to do this as a dict. So we can do params, and then response type is code. So this code is our authorization code that we're getting back. And this will let us get the token. We also need to provide the client ID, which could just be secrets client ID. We also need to provide the redirect URI, which we could just set as redirect URI. We need to provide the scopes, which in Google's case is space separated. I've seen them plus separated as well. So you may need to check your specific API to work out whether you need to put a plus or a space here. But you could just join all the scopes in like this and it'll be fine. We also want to provide a state token. And this is going to be hashlib.sha256 os.u. It had it for a second, and I think urandom 1024.hexdigest. So this state can be anything you want. It doesn't have to be this. I'm just using this because this is how Google did it in their documentation. But this state will allow us to prevent something called cross-site request forgery attacks. And that's where someone can intercept a request in the middle and then send a request back that looks legit but actually isn't. So we can pass this state up, and then if this state matches, then we know that it's come from the same place. And then for Google exclusively, we need to do access type offline. You don't need to do that normally. Google requires it, I think, anyway. It doesn't require it, but it's a setting that you sort of have to do, sort of. I don't know, I don't fully understand that bit, but it's not important anyway. So we can build our URL using this. So we could do secrets, our authorization URI. If it's not in a secrets file, you can define it as a constant up the top, and that's fine as well. And then we want to use our URL in code params. And what this URL encode does is it turns a dictionary of parameters into a query string. It misses out the question mark at the start, which is why we do this. But yeah, this basically allows you to build a full URL. And then we want to use the web browser library to open the URL. So we could do if not web browser.open URL like that, and then raise runtime error. And this will happen if the web browser failed to load. So if we couldn't open it for whatever reason, then you'll get this error. If you're following on with WSL, this won't work. You'll either need to print the thing into the terminal, or you'll need to install WSLU and go through those instructions, but I'm not talking about that right now. But you'll need to do that. So after that, we need to create a HTTP server that will run locally to listen out for a request that comes back. And to do that, we do server equals server, which we're going to create. And then we're going to pass host and port in. And then we're going to try server.handle request. And then we're going to finally server.server close. You can put error handling in here if you want. Like so for keyboard interrupts, you can have it exit a bit more gracefully, but we're not going to do that here. So to go at the top, to actually define our server, we first need to define a request handler. And this will inherit from base HTTP request handler. Then we need to define this do get, and that is actually pretty much what we want. Yeah, okay. Yeah, we'll just leave it as hello world. Before that, though, we do actually need to provide self-server, and that'll be server and then self.server.query params equals dict parse, and then we need to do .split. I'm doing this all, and I'll explain it all in one go because that's the only way it's going to make sense, and then do like that. So what we're doing here is we're handling our GET requests. And yes, it does have to be this, which is really annoying because it's not PEP8 or whatever. So we send a response 200. We then send a header to say that we want to pass a HTML document through. We then end the headers. We then provide a server instance so we can set the query parameters on the server. So we actually have something to reference back to on the other side. And then we simply just write some HTML in here, and this might actually, I'll do a H1 in here just to show that it's HTML, and we'll set this to authorized so it's a bit clearer what's going on. So this will be written out to the page. To actually define our server, we need to do this, and then we need to inherit from HTTP server. We then need to initialize it with a host and a port, and that's fine. And that will return none, like that. And then we want to do that. Yeah, so we want to pass the host and the port through as a tuple. And then we want to pass our request handler class through. And this will be used to handle the request. I believe if you don't pass this through, it will use the base one. And then we want to define query params to be a dict of string to string, which is going to equal an empty dictionary for now. And then we just want to, actually, we don't need to do anything else. So this is all our server's doing. All our logic is really in our request handler up here. And we're using parse QSL instead of parse QS. So parse QS returns a dict of the query parameter and a list of its values, which we don't want. And it's just easier to create a dict out of QSL, which returns a list of tuples instead. So if we come back down here, we've already done this code down here. So that's fine. That is our web server sorted. From there, I'm just finding where I am in my notes. There we go. So from there, we can assume at this point that we have our query parameters back. So we first need to check if our state that we created in our params is not equal to server.queryParam state. And if that's not the case, then we need to raise a runtime error, say invalid state, because if these two don't equal each other, there has been cross-site request forgery happening. If they do equal each other, then you can trust the response. So that's why we want to check that. The other thing we get back is the code. So we can do server.queryParameters code. And this is why we define query parameters on the server. And this is why we wrote the query parameters directly to this attribute so we could get it back. So now we need to fetch the access token. And yes, this is a lot of steps. It's security for you. So we need to set the grant type equal to authorization code, and this will tell the endpoint to send back our authorization code here. So we're now on this section here. We're requesting the access token and then getting it back. So we want our client ID again. We also now want our client secret. We also want our redirect URI, and we want to pass the code through. And then we can do with request.post, and it is a post. Secrets token URI, data params, that's all fine. As response, if response, oh my god, okay. I think that's fine. Actually, we can just return. We can return that directly. So what we're doing here is we are loading our token URI through. So this is different from our authorization URI. We send the data through as params, so here, and we're sending that through as an xwww form URL encoded thing. I don't know if you can send it through as JSON or not. I don't know if you'd really want to either, because well, yeah, it says encoded. I think it's probably just URL encoded rather than anything. But this is how I've always done it. So you could try with JSON if you want. We can then make sure that the response is 200, and if it isn't, then we just raise. You can probably raise something better than a runtime error, but I'm going to leave that as it is. And then we just want to return our response.json at the end, which are our tokens. So if we run this now, 20 odd minutes in, if we run this now, we will be kicked out into the browser, and I will load this up. Just had a bit of a cut for that zoom because I do want to censor a number of these email addresses. So we can click on this, and then we can click on this. So this is just the normal Google, YouTube authorization flow. Select all, continue, and then you can see we get flashbanged. If we look in the corner, we have this authorized up here. So it's all worked. If we come back to our code, we get a bit of a log to say what happened. We also get our tokens here. So we have our access token, and then it's this great big long thing here. We also get an expires in, which is always an hour minus a second. We get our refresh token, which will be important later. We then get a series of our scopes that the token is able to use. And then we get the token type, which is always bearer. Once we actually have the token, we can then check that the token is okay. And we can get some info about it. So if you do token info equals, and then we'll do check access token, which is something else we're going to be creating. And we just need to send through the access token. And then we can print the token info like that. And if we define our function here, check access token, and then we want that. Yeah, that's fine. That's also, and that's not fine at all. I'm going to rewrite that. Oh, the fun of AI. So with request.get, and then stop doing that. Oh my god. One small fight with an AI over. We could do with requests. Still trying to do it. .post, and then I'm actually going to copy and paste this entire URL in. I don't have a constant for it. You probably would want to define that. Oh, we don't want to do that. But I'm not going to here. And then we can just return response.json there. So we're just posting to that, and you do have to post to it. You don't have to send any data to it, but you do have to post to it. We can then check to see if the response status code is 200, and then we can return our token info. If we do that, and I'm going to quickly go through the authorization process again off camera, we can see this token info down here, and I'll highlight it so it's a bit easy to see. So we have various attributes to it. We have this AZP, AUD, scope, expiry time, expires in, and then the access type. You can use this to detect if a token is still valid. So at least for Google, if this returns a failure, then, or if it returns anything other than a 200, or it doesn't return anything at all, then the token needs to be refreshed. The access token isn't valid anymore. So you can use that. Basically, if you just get a normal response, it's fine. You can check it if you want, but a normal response is all right. But if you do want to refresh it, then we can refresh it like so. So we can do refreshed tokens equals refresh token. And this is another function we're going to do. And we want to pass the secrets, and then we want to pass our refresh token through. And then we'll do that. See, the AI is sometimes helpful. And then we can create a new function, def refresh token. That looks fine. I'm not going to trust it anymore with the contents. So we could do params once again. We want our grant type to be refresh token. So we're actually sending this off the token endpoint again. Before, where it was a grant type with authorization code, we're now saying that the grant type is refresh token. So we're now saying we don't want a new token, we want to refresh an existing one. And then we need to pass our client ID, we need to pass our client secret, and we need to pass our refresh token through. Once we've done that, we could do request.post, post the token URI, and then that's fine. So we do the same thing as we did before, where we send through our data as params, or our params as data, and we pass this content type to say we want it as a URL encoded, as response, and then that's fine, get rid of that bracket. So again, we're checking to see if the response type was 200 or not, and then we're just returning our response.json, which will be our refreshed tokens. So if I go through one more time, and I'm going to do this here so it's a bit clearer, we can see that we have our refresh tokens here. So you have our access token, we have our expiry time, we have our scopes, and we have our token type. And you'll notice that it doesn't return the refresh token with it. So you do need to store the refresh token if you do plan to use it, because when you actually refresh your token, you don't get the refresh token back. I guess probably for security reasons, I would imagine, but you do need to store that if you do want to refresh it. So what I haven't done here is I haven't made this smart. So you can use the token info to check if an access token is still valid. If it's not still valid, you can use the refresh token, or you can refresh your access token to get a new one. If you can't refresh it, you'll need to reauthorize from scratch. And this is how you can make it a bit smarter. So you can put this check in, say, is it valid? Yes. I'm just going to skip the rest of it, so you don't have to authorize every time like I just did. And you can use your refreshing and your existing tokens to authorize yourself. Generally, access tokens last an hour, and refresh tokens can last however long the token provider wants. For Google, that's 7 days. For other services, that could be longer, that could be 30 days, or it could even be infinite. But generally speaking, OAuth tokens last an hour. I don't know if there's a way to customize that. Either way, they don't last very long, and they're not designed to last for very long. One very quick thing before we end the video is that these scopes aren't the only scopes you can do. If you want something a bit more comprehensive, then you can use OpenID Connect. And the only difference between OAuth 2 normal and OpenID Connect are the scopes that you pass through. So again, these are slightly Googlified. Normally, you could just pass profile and email through in the same way that I'm passing OpenID here. With Google, I think you have to pass the full URLs. But if you pass OpenID and email, at the very least, then you get what's called a JWT user token back along with your other tokens. And then profile, I think, is a Google exclusive thing. So if you run through all that again, and you'll see actually on this page, we are asking for more details. So we're asking for info on our Google account, asking for personal information, and we're asking for the primary email. If we then continue that, we get flashbanged again, and you'll see our token is a lot longer. So it's still saying actually, the ID token comes back in the refresh tokens. I generally didn't know that. But if I come back up here, the tokens, you see it's a lot longer, and that's because we have this ID token. Now this is a JWT that I'm not going to talk about in this video because I've already done a video talking about JWTs before. So if you want to know about this, then go and watch that. But that is how you could get an ID token, and this is how you can get people's email. And I forget what else actually is included in that. I know the email is, and there's some other stuff in there as well. I don't remember. But yeah, let me know in the comments how you plan to use this. What sort of project ideas have you got that might need OAuth authorization or ID tokens or anything like that? I'd like to say a huge thank you to my amazing patrons and members on screen now, especially Mazard Rosherman III for being so generous. If you want to find out what's coming in Python 3.13, or you want to find out about a free Copilot alternative, then look at both of last week's videos. I did 2. It was a very special week that week. But I will see you next time for whatever we do next.